Alrighty, hello everyone. Welcome to another fun and exciting lesson to do with vectors today. Hope you're all going well in isolation. Um, this is my first video here to do with the vectors, so let's see how it goes. Might be rubbish, might be good. Let's see. All right, so today what we're looking at is the vector product or the vector cross product. And hopefully you've gone through chapter 5a prior to this, which is just an introduction to 3D vectors. So in today's lesson, going to be looking at the cross product. So from year 11 specialists, we know that the multiplication of two vectors using the dot product or the scalar product results in a scalar amount. Ooh, look at that, I'm highlighting that. How fancy. All right, so the vector product or the cross product is another method of multiplying vectors, which gives a vector result. So the scalar product gives a scalar answer. A vector product or the cross product gives a vector result. That's the difference between the two. So basically the way we write it is A cross B, so like that there, and you do an X sort of shape for that there. For that is the vector perpendicular to both A and B. So if we have a look in the diagram down here, what we can see is we can see two vectors. We can see vector A and vector B, and they form a plane. And this is true for any two vectors. So if you try to visualize, just do your thumb and your index finger, you sort of point them in any two directions, those two will form a plane. Now, when you do the cross product, is you're multiplying those two vectors, and that will give you a vector normal to that plane. And when we say normal to the plane, that means perpendicular. So that gives us this n1 and n2 here. Those two vectors are normal to both A and B. Okay, so that's sort of the visualization, what you've got to do there. Now, calculating the vector product. Okay, now if you have a look at the Sadler book, it's quite complicated, the process for that there. I'm going to go through the process here. You don't have to understand, what's going on necessarily, but it is important that you do know how to do this, because most of the time this comes up in exams. You need to do it with a non-calculator based. So here's a simplified method. So I'm going to write out a question for you. So I'm going to say here, forgive me if my handwriting's terrible. So let's just say we've got the vector C, and that's going to have the position 4, -1, and 3. And then I've got vector D as well. And vector D has position -1, 2, and -1. Okay, so three-dimensional vectors. So you've got I, J, and K reading downwards. So if I'm going to do the cross product, this is the method for doing it. So C cross D, and the cross you just write as an X. All right, so this is our process for doing this. So what I'm going to do is I'm going to list vector C horizontally 2 times over. So this is what I'm going to do. I'm going to do 4, -1, 3, and do it again. 4, -1, 3. There we go. Cool. Now let's do it with D as well, right underneath. So I'm going to go -1, 2, -1, -1, 2, -1. Oh, very cool. Watch this. I'm going to change pen colors. How fancy. Now, what I am interested in is just the middle 8 terms. So basically, I'm just going to draw a box around these ones here. So I'm just interested in these terms here. Just going to scroll down a little bit more, so I've got a bit more room. Now, what I'm going to do is, just like when we do matrix multiplication, we're going to do it like this. I'm just going to set up here. So I'm going to set up my C cross D is equal to, and it's going to give me a 3-dimensional vector. And so the first thing I'm going to do is I'm going to multiply these two together here. So -1 times -1 is going to give me 1. And then you take away the other multiplication. So 2 times 3 is 6. I'm going to do 1, take 6, like that there. Then I go across and I do the same thing again. 3 times -1 is going to be -3. Take away 4 times -1 is -4. And then do the last one. 4 2s are 8. Take away -1 times -1 is 1. Okay, so that's essentially what I do there. And then you just go ahead and simplify. 1 take 6 is -5. -3 plus 4 is 1. 8 take 1 is 7. That's the cross product. Woohoo! How easy is that? All right. Now your ClassPad can do this as well. So what I'm going to do is come over to, wait, let's go. So I'm going to do a new share. I'm going to share ClassPad Manager here. And here it is. Cool. So I'm going to put this over here. So we can see our vectors there. So what I'm going to do is show you how we do this. So on your keyboard, if you go down to Math 3, those brackets there are what we use for vectors, and we do it as a horizontal vector. So for -1, 3, I do 4, comma, -1, comma, 3. And so that's my vector C. I'm going to store that as vector X. Okay, so I'm going to do that. It's done that for me there. I'm going to come back up and do it again. So I'm going to do -1, 2, and -1. I'm going to store that for Y. So if I press now on a new line, if I go X, yep, it's going to give me, if I press Y, it's giving me those there. So how do I do the cross product? So it's nice and simple. Action, vector, cross P. And if I do the cross product of X and Y, it's going to give me a vector -5, 1, 7. And then you might be wondering, oh, what happens if I did the cross product of Y and X? So I'm going to redo it again. Here we go. Vector cross P, Y, comma, X. And look at that. It's pretty much done the exact same thing, except one is the negative of the other. And that comes back to the idea before where if I come back to, so new share, go back to this one here. So that brings me back up to this diagram that we're looking at originally. If you do the A cross B, it's going to give you a vector normal in one direction. And if you did B cross A, or the negative of AB, it goes in the other direction. Okay, so that's just need to keep that in mind there. So your ClassPad can do the exact same thing. I'm actually just going to go straight back to the ClassPad and just highlight one more point. So so we've done the cross product. It's given us a vector normal to that plane. So that means that if you were to now do the dot product of A, or in this case C and D with that cross product, it should give you 0 as an answer. So wait, I'm just going to come back here. If I was to do, if I had vector C, and if I did the dot product of that with the cross product, that should give me 0 as an answer, because it's saying that, well, those two are perpendicular. So let's do that. So now if I do, get my pen again. If I do the dot product of C with the cross product of C and D, that should equal to 0. So let's do it. So we've got 4, -1, 3. 4, -1, 3. The dot product of that with the cross product. So -5, 1, 7. What does it give us? Okay, so 4 times 5 is -20. Plus 1, take -1 is -1, plus 21. All right, I'm going to use our noggins, and yep, that's equal to 0. So there we go there. So basically, that's one thing to keep in mind. They might assess you on something like that there. The important thing is that you just know how to do this skill on a non-calculator. It pretty much always comes up as a non-calculator question. So just need to follow that process there. Now, one final thing to show you. Now, this isn't overly important, but Yeah, it's still just worth sort of thinking about this here. Now, I want us to think about what the absolute value is of the cross product of two vectors. And I know it's pretty hard to visualize, but there is a formula like this that you did in year 11 where you did the absolute value of A dot B, and that worked out to be, I think, absolute value of A multiplied by absolute value of C cos theta. I'll just write down here. So if I had, I think this was the one you had, A dot B is equal to, excuse the handwriting here. That's the formula you had previously. Well, there's one for the cross product, and it's pretty similar. So let's try and visualize that. So let's focus on that right-hand side. And we said that, so let's just draw out two vectors. It's going to do this. So there's A, there's B, and theta is the angle between them. Now, the height of that there, so that all the vertical component of that is just going to be the magnitude of A sine theta. And then if we draw the vectors head to tail sort of thing, like that, you can see it produces a parallelogram, you know, where that's B, that's A there. And so what is the area of that parallelogram? Well, the area is just simply, well, the base, which is just B, multiplied by the height, which is A sine theta. So we can write it like that there. So the area is that there, which works out to be, so that area works out to be the absolute value of the cross product. So now that doesn't give us any direction at all. So then if we were to say, I'll just write that, so that if n hat, maybe if I do it out, let's do this here, if n hat is a unit vector in the direction of then we can say that then A cross B is just simply going to be absolute value of A, B sine theta multiplied by n hat. Now, this formula is on your formula sheet. I haven't really seen any questions associated with this in any exam papers or anything, so I wouldn't be too concerned with it. But you might be called upon using this in some form, but I've got to find some appropriate questions where you would actually use this. So the key takeaway from today is knowing that if you've got two vectors and you multiply them together, you can produce a vector result that is perpendicular to those two vectors, and that's the method for doing it, and that's sort of the visualization of it there in that diagram. Alrighty, hope the video helps. Please complete chapter 5, 5B. That's what you need to be getting up to. So, and yeah, chapter 5A doesn't really need any introduction. It's just doing the key skills from that there. And so the next one I'll show you for chapter 5C, which is the, I'm basically going to go over all the stuff from chapter 4 again, but do it all in 3D. All right. Thanks, guys.